Hi viewers, welcome to Shapers Learning Academy. Let all your lives be filled with bright lights. So this video is dedicated to understand the basic concepts of electricity. Electricity is the prime energy or the primary source of energy which drives many equipments in today's world. Electricity is too an interesting as well as a fascinating subject. Let's understand more about electricity and the basis of electricity. Hope this video would have helped to understand the basis of electricity to a good extent. Thank you. Enjoy learning. Electricity or electric current is the flow of electrons in an electrical circuit. The SI unit of current is amperes. A basic electrical circuit can be defined as a electrical bulb, a switch and a power source. So when there are flow of electrons within the circuit, in a closed loop circuit, we call that as a flow of electricity. The standard defined unit used to measure current is amperes. Amperes. Electric charge. So before venturing into electrical charge, let me give a small introduction, a small pre-note. So if you like to understand electricity and physics, you are supposed to understand certain basics of chemistry too. Chemistry and physics are interrelated at various concepts. So any object, so let me give a small introduction in chemistry. Introducing the electrical charge and ions. So any object consists of atoms and molecules. Atoms are the lowest or the most smallest part of an object. Multiple atoms constitute a molecule, whereas atom can be still subdivided into subatomic particles or called as ions. So an atom will have a nucleus and will have various subatomic particles or ions revolving around the nucleus in concentric circles. So the ions can be either positively or negatively charged. So when an atom is considered to be positively charged, it means that he is ready to give out certain ions, and they are called as protons. When an atom is called negatively charged, it means that he is ready to accept subatomic particles or ions, and hence called as electrons. So electric charge is a physical property of matter that causes it to experience a force when placed in an electromagnetic field. So let us understand about electromagnetic field in the later part of the video. So here there are two types of electric charge, positive and negative. So positively called charges or ions are called as protons, and negatively charged ions are called as electrons. So like charges repel each other and unlike charges attract each other. So as I explained a basics of chemistry, here is a positively charged ion, positively charged atom, and he is ready to give out ions. So you can see the arrow mark is marked in the outward direction. It means that he is ready to give out ions. Whereas electrons, these are called as protons. Electrons are negatively charged and they are ready to accept ions. Hence you can see the arrow mark in the inward direction. So one common property is that like charges repel each other. Like charges, when you place a proton and proton, positive ion and positive ion, they repel each other, they move away. Whereas a negative charged electron and positive charge ion will attract each other. Electrical field. So an electrical field is a field or a space around an electrically charged object where any other electrically charged object will experience a force. In simple words, an electrical field is a subject of discussion area where an ion experiences a charge, where an ion experiences a charge. So when a proton and electron experiences a force, it means that that is existing inside an electrical field. So electrical field are of two types. One is uniform electrical field and one is non-uniform electrical field. When the intensity of the electrons or protons or ions are uniform throughout the electrical field, it means that it is uniform electrical field. When the intensity of ions are differing in the electrical field, they are called as non-uniform electrical field. Types of electrical current. There are two types of electric current. One is alternating current and another one is direct current. Alternating current is the norm of homes and industries in today's electrical environment. You see the lights, you see your refrigerators, you see your air conditioners, they all use electrical current. So electrical current is electrical current which periodically reverses the direction. So an electric current is actually indicated by sine waves. In India, we typically hold the electrical current of values 240 volts and 50 hertz. It means that 50 hertz is nothing but your frequency. Hertz is a SI unit of frequency. So this is one sinusoidal wave, and when you say 50 hertz, it means that per second the alternating current is capable of making 50 such sinusoidal waves. And typically the home appliances consume electricity of voltage 220 to 240 volts, some up to 260 volts. Direct current is one directional or unidirectional flow of electrical charge. So most of the storage electrical currents, batteries, battery banks, they come under this direct current model. Conductors and insulators. These are the most important element or most important building block of an electrical circuit. An electrical conductor is defined as the materials that allow the electricity to flow through them easily. This property of conductors that allow them to conduct electricity is known as conductivity. Most of the elements, most of the metals are conductors. You can see any transmission wire or any object which carries electricity will be made up of some metal. And these are the 5 common electrical conductors: silver, gold, copper, steel, seawater. And 90% of the time you would see the conduction of electricity is either through copper or steel. Whereas insulators are the materials that hinder the flow of electrons from one particle of the element to the other. Insulators block the flow of electricity. Rubber, glass, oil, diamond, dry wood. These are the common electrical insulators. You would have observed that when an electrician works on some of our electrical apparatus in a home, he puts on a rubber slippers. It means that he is trying to cut the electrical circuit. He is trying to use an insulator to protect himself from the electrical shock. Resistance or voltage. These are the two important terms in electrical wall. Resistance is a measure of opposition. Resistance is a measure of opposition to the electrical flow in an electrical circuit. Resistance is measured in ohms, symbolized by Greek letter omega. So this is a typical circuit, typical indication of resistance, and you see this is the actual symbol of resistance. It means that this resistance is capable of 3 ohms. He has a capacitor. He has capacity of 3 ohms of resistance. To explain resistance in the most common words, you would have seen a ceiling fan. A ceiling fan runs at maximum at number 5 or number 6 in certain plants, and it runs at slower speeds in number 1. It means that at number 1 position, the resistance of the ceiling fan is the highest, and at number 5, the resistance is the lowest. Voltage. The voltage between 2 points is a short name for the electrical force that would drive an electrical current between these points. See, electrical voltage is the energy that pushes the electric current. The push of an electrical current is defined as a voltage in common words, whereas voltage in technical terms is a product of the current and the resistance, and this is called as Ohm's law. If you are trying to measure the voltage of certain system, you are supposed to multiply the current and the resistance of that particular system. So you get the voltage value of that particular system. Electrical circuit. An electrical circuit is a closed loop made up of conductors and other electrical elements through which an electrical current can flow. For example, a very simple electrical circuit consists of three elements: a battery, lamp, and an electrical wire that connects the two. So here you have the lamp, here you have the electrical source, and here you have the conductivity element. So the flow of electrons is the electrical circuit. This is the working of an electrical circuit. Last but not the least, tribute to the founders. These four gentlemen are the ones who are responsible for the advantages or the advancements in the electrical circuit that we are experiencing today. Today you see a light that's glowing on your home. Please thank these four people or either one of them. So first is scientist Benjamin Franklin. Benjamin Franklin is the first-most person who discovered that the lightning is a form of electrical source. So he understood, he experimented electricity and tried to understand electricity from lightning with the kite experiment. He is scientist Michael Faraday. Michael Faraday is the father of electromagnetic induction. So earlier I said, there was a word called as, there was a mentioning called as electromagnetic induction. I told, okay, well, let's discuss about in the later part of the video. So electromagnetism is the concept of inducing current to a conductor and making that as a magnet. So this concept is called as electromagnetism, and this has played a wonderful role in the electrical technology. So Michael Faraday is the father of electromagnetic induction. Nikola Tesla. Scientist Nikola Tesla is the father of alternating current, and alternating current is the prime factor of any industrial application or the home appliances which you are witnessing right now. Thomas Alva Edison has done extensive research in the transmission of electricity. So when you understand that the electricity is being transmitted and it reaches your home, just thank Thomas Alva Edison. One additional information is that an electrical current travels from the southernmost tip of India to the northernmost tip of India in 6 seconds. So just imagine an electrical switch is switched on from Kanyakumari. It reaches the northern part of Kashmir in 6 seconds. Hope this information would have been interesting to you. Thank you. Thanks for understanding the basis of electricity. Let's understand more about electrical circuits and electrical technology in the further videos. Thank you.